have last time. The only way it would still be there is if it was in the original. Yeah, we must go. Okay, everybody. Good question.
That was good, thank you.
Yeah.
Yeah, because I'm visualizing these things from, you know.
Yeah,
it
no,
doesn't
the
exist
difference
bigger
is
somewhere down there.
it's
Yeah.
either in the galaxy or it's out of it.
Yeah, yeah, yeah.
I'm going to clarify something. Because I had a good question. And it was about the stretching out and expansion of the universe. It's the expansion and the stretching is occurring between the galaxies. In the galaxies, things are staying pretty much as they've always been. So in our galaxy, all the rules apply. If a star blows up in our galaxy, we'll know about it, believe me, we'll see it if it's a supernova, and it'll come at us as well as go away from us. Everything in our galaxy right now and our little solar system is just fine. It's the universe between us and the other galaxies that is stretching. And yeah, there is a galaxy coming at us. It's the Andromeda Galaxy. It's bigger than us, and it's heading to us, and it'll collide with it in a few million years. But we don't have to worry about that because there won't be an Earth worth living on by that time. And it's not because of us, but it's simply because the sun started out weak, 30% weaker, and it's getting stronger all the time. So in about 1 billion years, the sun will be so strong that it will have boiled away all the oceans. But we won't worry about that because the Earth's magnetic field will probably have failed by that time too. And without a magnetic field, we couldn't be protected from solar radiation, and so we'd all be fried and die. So before 1 billion years, it's all over. I figure we got at least another couple of 100 million years, good years on the planet if we, so choose to make use of it. So I just wanted to illustrate then that it's space-time that is stretching. It's not in the galaxies. Einstein, let's have number 30. Einstein could not deal with the fact that the universe was expanding. Hated it. So he came up with a thing called the cosmological constant in 1917 to fix his equations and make his equations say that the universe wouldn't expand. Bam, back universe. So I put in the cosmological constant. The problem, okay, so we put in the cosmological constant. For the next 20 or 30 years, nobody knew if he was right or if the other guys were right. But it was finally proven that the other guys were right over and over and over and over and over. There is such a thing as quantum mechanics. There are such things as bosons. They don't obey the kind of Pauli exclusion laws that they should. It's pretty weird. I don't want to give you the idea that it's totally random. It's not. There are rules. Remember, light can only move in quantum. There are rules. You can't just do anything, but the rules are different. That's all. They're weird rules, and it's a weird universe. So the people I talked about last time figured a lot of that out, including Einstein. But he came up with the cosmological constant, which made the universe stay still. Now get this. And then, in 1929, remember, Edwin Hubble announced that the universe was expanding. So Einstein thought, and he visited Hubble at the observatory, and he said, yeah, you're right, I admit it. One thing I like, at least he did admit he was wrong. Oh yeah, the cosmological constant. Turns out, remember I told you in 1998 that it was discovered that the universe was expanding faster all the time? The rate by which it's expanding faster all the time, which is due to dark energy, was the exact cosmological constant that Einstein came up with. So when Einstein said, this is my greatest blunder, even when he was wrong, he was right, in a way. It's just crazy. Anyhow, so evolution is the evolution of an old idea. All Charles Darwin did, I shouldn't say all he did, this was huge. He had the insight that it's natural selection that makes it work. That's all. The other guys didn't know how it worked. Which brings me up to this guy, Wegener. Alfred Wegener. Is that a name on everybody's lips? Is that a household name? I know you guys are like, you've got pictures of Mendeleev and the periodic table on your walls at home. And you've probably composed poems to Alfred Wegener, and now you're just holding out at me anyway. Alfred Wegener, isn't that a great picture? Now this guy is my idea of a scientist and a leader. Alfred Wegener was a meteorologist, a climatologist who was interested in doing work on the Greenland ice sheets. In 1912, Alfred Wegener, after looking at a map, oh, by the way, we've got these pictures up, I gotta show you that. Well, no, I'll talk to you about it in a minute. Show us the map first.
Which
If
one,
you-
hon?
It's that one of Pangaea,
Okay.
where Wegener looks at it and he sees how the continents are, that's it.
Oh, yeah.
Wegener looked at an old map of the Earth, or he looked at the Earth as he thought it would have been 330 million years ago when the supercontinent Pangaea was being assembled. Wegener looked at the positions of the ancient continents and he thought to himself, this cannot be a coincidence that Africa and South America, wait a minute, I've got a thing around here someplace. Is this my laser thing?
Yeah, just press the button.
Okay. Sec. Oh, I've got to hold it. Okay.
Yes.
All right, so Wegener looked and saw the way that South America did it into Africa. And he thought that cannot be a coincidence. And then he looked at some species of animals, 3 types of therapsids and 1 type of plant, and saw that those animals and plants were distributed all over. Not just on one, but on all of them. So he thought, not only did I fit together, but the fact that these ancient species were found on all of them shows that they were joined. So in 1912, he presented his thesis to an assemblage of geologists, and they laughed at him. Not only did they laugh, but they cursed him. They didn't like the idea that a non-geologist was messing in their territory. And they said, well, yeah, how could the continents have moved? How come they're not there anymore? Nobody could come up with a good solution. The defenders of the status quo said, well, there used to be land bridges, and there was a flood. Yeah? Well, nobody had a good mechanism, all right? Now, should I tell them about Wilson next, or I gotta
Yeah.
tell you, I got to go back to Wegener while we're
Oh,
on
okay.
Wegener,
Yeah, yeah,
So,
okay.
this is the theory that Wegener came up with. I'm gonna look at the modern version in a minute. Why I wanted to go back to this was, he made 4 expeditions to Greenland. And those are the things that they invented to take to Greenland. That thing over there, just a sec, is the world's first snowmobile. That's a snowmobile made out of plywood. And that's what, that kind of stuff that Wegener had in his later expeditions. On his first expedition, let me think, he was there from about 1912 to about 1930. So the first expedition, the leader of it fell down a crevasse and broke his leg. Second expedition, he and his party ran out of food. Everybody ran out of food. So they ate their dogs, and they ate the ponies. What was next, I don't know, but they got rescued just in time. On the third expedition, Wegener's partner got frostbite and they had to cut his they cut his toes off with a penknife, no anesthetic. And on the last one, Wegener thought that his men in the interior were in trouble, were running out of food and supplies, so he organized an expedition to go rescue them. And he and this young guy named Rasmus somebody, the guy was 23, Wegener's 50, okay? Wegener smoked like a chimney. Anyway, these guys are heading in. Again, this is why I like Wegener. Wegener's 50 and he's on skis and he's got the young guy on the sled. Here's a guy who's leading. He's not telling other people to go out there and get poop all over them. He's doing it himself. I admire that man to no end. Anyway, they never made it back. They never found Rasmus's body. Rasmus found buried Wegener in the snow, and he put 2 skis up as a cross to mark his grave. Now remember, Wegener invented the theory of continental drift, the idea that the continents move. Right? That's what came out of this. So Wegener dies. He's in the middle of Greenland. They bury him in the snow. His body disappears. Nobody knows where it is. But somewhere in Greenland is Wegener's body, and it's not where it was buried. Because A, glaciers move, but B, so do the continents. Isn't that cool? So Wegener's body is now no longer where it used to be. Iceland isn't moving very fast, or Greenland. Like you've probably read sites that say the continents move as fast as your fingernails, right? Yeah, well, some do, but most of them move about the same rate as your toenails, which is about maybe 3 centimeters a year. Yeah. Anyway, my point is that Jupiter's body moved. Some places move faster than others, while we're on the subject of plate tectonics. Take Australia. Well, kind of hard, it's big. But anyway, if Australia has moved, they took a satellite image of Australia in 1996, and when they took another one recently, Australia had moved over 2 meters. Isn't that something? Now, if you add that up over a long period of time, that's a lot of movement, right? So that's why it's not hard to imagine, based on that when the dinosaurs went extinct, those continents that I showed you that used to be together had moved part way apart, and now they're further apart than ever. And in another couple of 100 million years, they'll all be in totally different places again. They're moving around and around and around the Earth. I got a diagram of the Earth. Should I show them how it works, son, or maybe move on to? Yeah, I'll leave plate tectonics maybe for another time, and just try to finish off so I can kind of end up where I want to end up. So last time we essentially did the Big Bang, and we got to the point where 9.2 billion years had passed, and we're now going to take a look at our part of the universe and look at how our solar system evolved. So, I don't know, I've got number 40 here. Let's try it and see.
No, that's a periodic table.
Is it?
You want the solar system?
The solar system, yeah. These are theories of the origin of life. I was going to do that after. I had to do the solar system first. Must be back here. If I can't find it, I'll just do it from memory. Oh, there it is. Okay, 4.6 billion years ago. Show us our molecular cloud, baby. There was a giant, once upon a time, 4.6 billion years ago, in the Orion arm of the Milky Way galaxy. Milky Way is 54. Let's take a look at our galaxy. It's hard to look at because we're in it, but that's a rendition of what we think it looks like. So you can see it's a nice barred galaxy, a barred spiral galaxy. Beautiful looking thing, I think. Anyway, that's where our sun is. Oh, I've got a pointer. So. Let's take a look. Yeah, so that's where we are there. Now let's take a look at number 42.
Why?
I don't know what, pardon?
Why?
Oh, so that's the way it's going to be, is it? You're eliciting all this sympathy. This is the burden that I must bear, right? The burden of the world upon my shoulders.
What is it you want to look
Having
at?
to deal with this intransigent and recalcitrant individual.
What is it you want to look at?
I don't know, that might have been a horrible mistake. At any rate,
We were
how
at
about a
the-
molecular cloud? Did we do a molecular cloud?
No, that's what
I'd be happy with a molecular cloud. Okay, off in the area where I showed you, there's a giant molecular cloud. What's a molecular cloud? It's what left after stars have blown up and thrown their stuff all over the universe. So a molecular cloud is a giant cloud of dust and gas, hydrogen, helium, and a few of all those other elements that I showed you on the periodic table. What happens is a supernova goes off. A supernova is what a big star does when it dies. Remember I said they blew up and blew their stuff everywhere? That's a supernova. There's different kinds, doesn't matter. They're really bright. If one went off, we'd know it. One went off in 1054 BC. How do we know? There's a place in the southern United States where the local Indians put it as a petroglyph on an overhang. You know, those Pueblo areas down there in the southwest U.S. Well, if you go down there, I didn't go to it. I missed out a lot of things in my life. I've really missed out a lot of cool things. I've seen some, thank God. I've been and seen the Bristlecone Pines and a few other things, but I did not go and see that. But
Okay, so they
What's
saw
he
it at
talking about?
they saw it at 1054.
sorry.
They saw a supernova in 1054.
Yeah. So anyway, yeah. Oh, in 1054, right? So one went off, and the Indians recorded it.
And who
Well,
else?
That's how bright it is, okay? Right, you can see it, obviously, at night and probably in the daytime too. When those things go off, they're usually visible in the day. Now, the neat thing is that in 1572, when William Shakespeare was 8, there was a supernova. in 1604, which is when he was around, well, 1616 is when he died. So in 1604, there was another one, 2 in one lifetime. And as I told you last time, Shakespeare's lifetime coincided with that of one of the greatest astronomers, Johannes Kepler. And so Kepler saw it too, and it's called Kepler's supernova. But those are the kind of things that when they go off, shock molecular clouds, okay? That's Galileo. Isn't that Galileo?
No, it's Kepler,
Oh, is that Kepler?
and it's supernova.
Oh, okay, well, cool, thanks. Well, there's Kepler and his supernova. That thing in the middle means something. What Kepler came up with was the idea that, see, that planets evolve in ellipses. They can't go in circles. They have to go in ellipses. Right now, we're in an ellipse around the sun. One of the reasons for glacial periods is that the way we go around the sun varies. The Earth is tilted on its axis. It tilts between 23.1 and 24.5 over a period of 41,000 years. Why do we care? Because it's that period that determines probably whether we're going to go into an ice age or not. Because although it may not sound like much, the difference between one and the other is huge. Right now, let me think, it's spring. We were closest to the sun on January the 4th and will be farthest away from it on July the 5th. Why am I saying that? I'm not sure, but it has to do with the climates and the seasons. Okay, right now,